So that brings us to today's topic, but before we begin, review what we learned in the previous lesson. We talked about a relation. A relation is a set of ordered pairs. We have a value of x and a corresponding value of y. Some relations can be broken down into functions. Remember, a function has to pass the vertical line test, which means for every single value that you have in your domain, you should only get one value in your range. So if I plug in a 0 for x, I should only get one value for my y, not two. We can break down a relation that is not a function into smaller pieces that are functions, and that's called implicity. So if we use this as an example where we had y squared is equal to 4 minus x squared, if I take the square root of both sides, I get two implicit functions, each of which I can graph on my graphing calculator without having any problems. And even though they are not technically functions, the individual pieces can be functions. And then we also, yesterday, talked about piecewise defined functions. Piecewise functions are functions that model different behaviors over different sets of intervals on my x. And we looked at a couple of examples. So if my x value is less than 0, then my y function may be a line. If it's greater than or equal to 0, then my function may look more like a curve or a parabola or something of that nature. So those are piecewise functions. They can be broken, they can be discontinuous or continuous depending on what those values are. Step functions are a specific type of piecewise function. And so that brings us to today's topic, which is parametric functions. Now, on the very first day of school, we kind of worked out a parametric type of function. Today, we're going to be looking a little bit more into it. We don't get into parametrics very much in this class until the very end of the year, where if we have time, we will cover more on parametrics. When you have an ordered pair, such as x, y, changes in relationship to another variable, such as time, it is known as a parameter. So basically what we're saying is that you have two values, x and y, that could be at a particular point in time. However, as time continues on, that x and y value may change, that location. In our example at the very beginning of the year, we had a lion and a ranger that were both moving in relationship to time, and at one point their paths crossed, but they did not cross at the same time. So they never actually met each other, although they were at the same location at one point in time or another, just not at the same exact time. So that's a parameter. We have certain parameters that must be met in order for us to solve particular types of problems. If x is equal to t plus 1 and y is equal to t squared plus 2t, what points are determined when t is equal to negative 3, negative 2, negative 1, 0, 1, 2, and 3? Well, I'll give you a moment to think about it. How do you think you would find this particular portion out? If you said substitution, you are absolutely correct. So if I substitute in that negative 3, I get a negative 3 plus 1 for my x value, which would be negative 2. If I plug in a negative 3 for my y, I get negative 3 squared, which is positive 9, plus 2 times negative 3, which is negative 6. So I have 9 minus 6, which is a positive 3. So negative 2, 3 is going to be my value when t is equal to negative 3. Plugged in a negative 2, you should have gotten negative 1, 0 as your point. Plugged in a negative 1, you should get a 0, negative 1 as your x and y values. You plugged in a 0, you should have gotten 0, 1. You plugged in a 1, you should have gotten 2, 3. You plugged in a 2, you should have had a point at 3, 8. Or you plugged in a 3, you should have had 4, 15 as your final answer. So hopefully that makes sense to you. It's fairly easy. It is going to get a little bit more complicated, but we're just going to hit the basics today. Nothing to be real concerned about. Based on this information, what is an algebraic relationship between x and y? So could we come up with an algebraic equation that gives me these same values for x and for y? So let's take a look at how we can get this into more of an algebraic equation where we get rid of the t's altogether and all we have are x's and y's. Now if you take a look at our y equation was t squared plus 2t. Well, what I want to do is I want to substitute in for that value of t. What do I want to substitute in? I want to substitute anything that has more of the x look. So if I take a look at x is equal to t plus 1, if I solve for t in that equation, I get t is equal to x minus 1. Now that I know that t is equal to x minus 1, I can start substituting in my other equation to solve. So if we have t is equal to x minus 1, taking my original y value of t squared plus 2t, substituting in the x minus 1 in anywhere where I have a t in my y function, and then I can distribute. So I have y is equal to the quantity x minus 1 squared plus 2 times my t value, which is again x minus 1. Distributing that x minus 1 squared piece, that gives me x squared minus 2x plus 1. And then if I distribute the 2 times the x minus 1, I get 2x minus 2. And then I can combine my like terms, giving me y is equal to x squared minus 1. Now, let's see if it actually works out. Y is equal to x squared minus 1. So when I plugged in a negative 2 for my x value, using this equation, negative 2 squared is a positive 4 minus 1 does indeed give me the 3. If I try another one, such as the 0, if I plug in a 0 here, I get negative 1, and that works out as well. All of them would work out. We've now changed my parametric into an algebraic type of equation. If we were to graph this particular one, it would look like a parabola, because obviously this is a parabolic form, x squared minus 1. That happens to be the basic parabola that has been shifted down one value. So it looks something like that. And if you notice, those points fall right along my parabola shape here. Now, let's use a calculator to help us with these. It says use a calculator if x is equal to t plus 1 and y is equal to t squared plus 2t. What points are determined by the negative 3, negative 2, negative 1, 0, 1, 2, 3? Rather than plugging each one in individually, let's use our calculators to do this. First thing you want to do is take your calculator out, turn it on, and press your mode key. If you scroll down, on mine it has whether it's normal, scientific, engineering, then we have floating, the next one down is radian or degree, the next one down is function, but we want to arrow over to where it says par, or yours might say parametric. So go ahead and scroll over there, hit enter, and then we want to quit out of that. So that's the second key quit mode button. Now press your y equals key, and instead of y sub 1, y sub 2, y sub 3, you'll notice that it looks a little bit different. So when you enter in these equations, we want to enter in the equations for both the x and the y equations. So if there's anything there, just go ahead and clear all of your lines out. And where it says x sub 1t, we are going to enter in t plus 1. Now to get to t, you're going to hit your variable keys. You'll see that there's an x, a t, a theta, and an n. When you press that button, rather than putting in an x like it normally would, it's going to put in a t. And then we plus 1, hit enter, it'll go down to y sub 1. And y sub 1, we're going to hit our variable key of x, or in this case, it's going to put in a t. We want to square that, so hit your squared key, and then plus 2t, and hit enter. Now, if you hit second function window, that's going to be your table set function. It's going to ask you, where do you want your table to start? We want our table to start at negative 3. So if you hit negative 3, make sure you hit the negative key, not the minus key. And we're going to change our table to go up by ones. So in that delta table line, just leave it as a 1. If it's not a 1, make it a 1. And then you can hit quit or second function mode. And now press your table button, which is the second function graph. And you will see that you have a t value. And our t values start at the -3, then -2, -1, 0. Next column, it has your x value. That should be reading as -2, -1, 0, 1, 2, 3, 4. And then your last column that you could probably see on your screen is your y sub 1. And that should give you values of 3, 0, -1, 0, 3, 8, and 15. The same values that we had before, but now we used our calculator to figure them all out instead of individually having to figure them out. This is very helpful if you're having to do a lot of different values, not just 2 or 3. Probably not going to save you a whole lot of time if you're just doing 3, 2, 3, maybe even 4 values that you're looking for. But if you're doing more than 4, it's probably going to be worth the time to use your calculator and set it up on your table. Graphing can also be done using your graphing calculator. So on your calculator, now press the window key and change the following. Again, it looks a little bit different from what it was before. And your t minimum, go ahead and hit -4. And your t max, enter 2. And we're going to step it up by 1s each time. So press 1, enter. The next line down is your x minimum. We're going to enter in a -5. Hit enter. Your x maximum, we're going to put as 5. Hit enter. Your x scale, we're going to leave as 1. So if it's not 1, enter 1. If it is 1, you can just leave it. Your y minimum, we're going to put as -3. The y maximum as 3. And the y scale also as 1. Now, if you press your graph button, you will see that it does indeed graph. Now, you'll notice that it looks very much like a parabola, but it's kind of choppy. It kind of has almost straight lines to it. So what I would like you to do is I'd like you to change your window once again. So press your window key and change the t step. So you have t minimum still at -4, t max at 2, but change your t step to be 0.1 instead of 1. And now hit your graph button, and you will see that it tends to be a much more smooth type of curve. So the smaller that value of your t-step is, the more of a curve you're going to get in your graph when you're doing parametrics. So in review, when you have an ordered pair, and your ordered pair changes in relationship to another variable, such as time, that is what we call a parametric or a parameter. Parametric equations are values of x and y that both relate to a third variable, that usually of t. And an equivalent algebraic expression can be derived from your parametric equation by solving for t in one of your two equations. Usually I solve for t in my x equation and substitute that into my y equation, because on our graphing calculators we normally have y equals when we graph something. So it just makes it a little bit easier for the most part to do it that way. But really, technically, you could do either one. We derive one equation by substituting in that value of x into, or that value of t into the other equation, and then we now have an algebraic equation that we can use in several different ways.